Discovery Channel. I am Sarah Hakeem and I am reporting live from Mount Etna, Italy. As you can see, a volcano erupted a short while ago and is still emitting gases. As a CCE major currently taking Geology 205 with Dr. Hamad, I will be explaining the formation of such volcanoes in addition to other volcanoes and will be giving a brief overview about plate tectonics. I will firstly give a short introduction about plate tectonics. The surface of the Earth is made up of rigid plates that move lightly each year atop of the partly molten mantle beneath the crust. Volcanoes are the manifestation of these plate tectonics processes. Volcanoes are common along the convergent and divergent plate boundaries, such as all around the Pacific Plate. A volcano is an opening in the Earth's crust that allows molten rock to reach the surface. It is formed when magma from within the Earth's upper mantle works its way to the surface. Now remember from the rock cycle how we get molten rocks. If we start from igneous rocks, we have weathering of rocks at the surface, followed by erosion and transport. Afterwards, we get the deposition of sediments near the ocean, which is followed by burial and compaction and end up giving us sedimentary rocks. These sedimentary rocks go through deformation and metamorphism because of heat and pressure and give us metamorphic rocks. These metamorphic rocks end up melting and finally give us the magma. When the volcano erupts, we have material that comes out of it, such as lava, which comes from magma. We also have gas, ash, and broken rock pieces. As I have mentioned before, the Earth's plates are in movement. The friction caused by these plates cause earthquakes and volcanic eruptions near the edges of the plates. This is what we call plate tectonics. Sometimes the plates crash together, pull apart, or sideswipe each other. 90% of volcanism is due to plate boundaries. Out of these 90%, 10% occur at subduction zones. The other 80% occur at spreading centers. And finally, the remaining 10% of volcanism occur above hotspots. At spreading centers, we have divergent plate boundaries. This usually occurs between two oceanic plates when they pull apart from each other. In this case, we have hot mantle rock that rises into the space. This releases pressure on the mantle, which lowers the melting temperature. Lava then erupts through the fissures. Usually, at spreading centers, the volcano is not very dangerous. This is due to the fact that the lava flows calmly. This is what we call basaltic magma. It is the least explosive as it is mafic. Mafic means it is low in silicon but high in iron and magnesium. It also has a low viscosity. At subduction zones, if at least one of the converging plates is oceanic, then the oceanic plate will subduct, creating a volcano. The subducting plate heats up as it is sinking into the mantle, while water gets mixed up with the sediments on top of the subducting plate, lowering the melting point of the mantle material. Rising magma melts the continental crust and thus goes through a change of composition. We thus get either antizetic magma, which is intermediate, or rhyolitic magma, which is felsic, both of which are very explosive due to the intermediate to high viscosity. At hotspots, the volcanic regions are fed by the underlying mantle that is extremely hot. Hotspots are places within the mantle where rocks melt to generate magma. The melting of the rocks rises through cracks and erupts from the volcano. Most hotspots volcanoes are basaltic and thus aren't very explosive. To conclude, there are several ways to form volcanoes. Most volcanoes are formed due to plate boundaries, mainly due to spreading centers, i.e. divergent zones. We also have volcanoes as a result of subduction zones, such as convergence of oceanic plates. And finally, the small minority occurs above hotspots.